Well, hello everyone. This is KP the Math G. Let me shut this door so I won't interrupt my wife, whatever she's doing over there. Anyway, we're dealing with partial fractions, and I just want to say that I did a video just about 20 minutes ago, and I will tell you that I got right down to the very end of it. This is a longer problem than this one here. I had to pick a shorter one. But anyway, this shorter one will give you what I'm wanting to show you anyway. It's just, this has to be shorter. I went all the way up to the 32-minute limit, which this camera gives me. And I knew I was cutting it short, but it cut me off. So I'm not going to do a video where I'm getting cut off right with the last 2 or 3 minutes of the video left. I had probably 3 to 5 minutes and I would have been through, but oh, it's not going to give it to me. Anyway, this is a shorter problem and probably better anyway. Let's take this integrand off of here for the time being. We'll put it back up there, but for right now we're just going to just take this off, and I want to factor this. And you'll see, if you haven't already seen this, this factors in the x minus 3 times x minus 3, doesn't it? We know that x times x is x squared, but negative 3 plus negative 3 is negative 6, and negative 3 times negative 3 is positive 9. So you get the same thing here. Okay, we could rewrite this as x plus 2 over x minus 3 squared, right? Okay, like that. And so what we got to do is, when we set up partial fractions, we're going to have it in the form of a over something plus b. Since we have two factors, we need to have two letters. If I had an x over here on the side, I would have had to have a plus c. Okay, but I only have two factors. So ever how many factors you have, that's how many letters you're going to have. Okay, that's the key to this. So the first thing you got to do is think, well, we could have an x minus 3 underneath here, or the whole thing could be x minus 3 squared, like that. Anytime you have a square, you're going to go this to the first, this to the second. Had this been a cube, you would have had a plus c over x minus 3 to the third power. But you don't. Alright, so what we're going to do is, that's how you set it up. And our goal is to find what is a and what is b, and then we're going to set up the integrand for all three of these, and then we're going to figure out what this right side is. Okay, but if I don't know a and b, I don't know what the final answer is going to be. So let's figure out how we can do that. And one way to do it is simply to multiply up and down by the denominator. Okay, and I'm just going to say on this one, x minus 3 squared is x minus 3 times x minus 3. And this one here, I'm going to just put x minus 3 squared, like that. It doesn't matter how you write it, it's just I'm doing this for a reason here. Okay, well, I know that x minus 3 squared over here on this side is just going to divide out, so I'm just left on this side with x plus 2. And then one of these x minus 3's is going to cancel out, so I'm going to cancel out this one with this one. So I'm left with a times x minus 3. Okay, this one has both of them, so I can cancel both of these out or divide out. I don't like to say cancel. I'm just left with b, right? This little long b. Put a 1 in front of this. I don't know why. Okay. There's a reason for it, but it's okay. Now, I could multiply. Some people multiply a times x, a times 3, and they set up a system of equations. I'm going to try to show you how to do this without doing a system of equations. Now, sometimes it's better to do a system of equations because you can see the answers really quickly, but this is okay here. Now let's put it up here where we can work with it just a little bit. So let's put it up here. We may have to flip our board over. That's okay. Let's see, we got x plus 2. X plus 2 is equal to a times x minus 3 plus b. It's important that you get every sign correctly. All of this needs to be done correctly, okay? Keep in mind that this originally was a over x minus 3. This was b over x minus 3 squared. Keep that in mind. That's what we had originally. We didn't really mark this out. We've got to come back to it later. Well, you'll see what I'm talking about. Now, we need to get rid of a. I think I can get rid of a if I let x be something, some number, I can quickly get rid of a. If x is, what do you think? Yeah, 3. Yeah, x is 3. See, 3 minus 3 is 0. I want that, okay? So if x is 3, so I'm going to let x be 3. Let x be equal to 3. Alright, so I've got to plug it in on both sides. Wherever there's an x, I'm going to plug that 3 in here. So 3 plus 2 is equal to a times 3 minus 3, which we know is 0, plus b. So this is just 5. This is a times 0, which is just 0. And then this is b. So b obviously equals to 5. So somewhere over here I'm going to say b equals 5. Now the thing is, what number do we substitute to find out what a is? Because if I can't let a be 3, x be 3 again, that's just going to lead me to b is equal to 5. So I need a different number than just x being 3. Alright. So let's erase this top here. Okay. Alright. I have an eraser somewhere, but I'm just going to use this cloth. Alright, so then we'll erase this part right here. And we're going to use this again. Alright. Alright, here we go. Now, what do we want to let x be? Well, I can't let it be 3 because that's just going to give me back to b is equal to 5. Okay. So let's try a different number. And I'm going to show you in just a moment that I can let x be any number and I'll still get the same answer for a. Well, let's let x, I'll tell you what, let's let x be 4. And I'm going to show you one. It doesn't matter. 4 plus 2. X is 4. So 4 plus 2 is equal to a, 4 minus 3, plus b. Oh, I already know what b is. B is 5. Oh, I don't need to put plus b again. So I'm going to let b be what it is. B is 5. Once you find one, that's the key, that once you find a letter, plug that number back in place of that. And we let x be 4, so we've already taken care of x and b. So now we just got to find this lonely a. Well, 4 plus 2 is 6. 4 minus 3 is 1, plus 5. And then if I subtract 5 to both sides, I see what a is. So 1a is equal to 1, which means that a itself is equal to 1. Alright, 1 is equal to a. So a is equal to 1. Somebody may ask, well, KP to Math G, will plugging in, if I let x be something else, say, I don't know, let's let x be -1. If I let x be -1, will I get the same thing? Well, of course, we're saying this side is equal to this side, right? So it better work out. Well, let's let x be negative 1. Alright, okay, alright, we'll do that. Okay, negative 1. Negative 1 plus 2 is a times negative 1, minus 3. Minus 3. Now remember, b is always 5. We done found that out. Alright, so this is negative 1 plus 2 is 1. So a, this is negative 4. And still plus 5, right? Alright, I'm going to subtract 5 on both sides. And look what's happening. This side is negative 4. This is negative 4a. And if I divide both sides by negative 4, well, a is still equal to 1. So it doesn't matter what we do with that. Okay. We have our two numbers. That's the key. But I wanted to show you that you could plug in any number that you wanted. We plugged in 4 a while ago and got 1. And now we plugged in negative 1 and we still got 1. You don't have to keep doing this. A is still going to be 1 no matter what number you plug in. We couldn't plug in 3 because that just eliminates a altogether, doesn't it? Alright, so we didn't want to do that. And we already knew that b was 5. So that's the beauty in this. Okay. Again, some of you have done this by setting up a system of two equations. I know that, and you can do that, but I don't know if time will permit me to show the other way, so I will not do that. Alright, so I know that a is 1 and b is 5. Okay. Let's flip the board over so we can kind of have a fresh look at this. So I'm integrating this now, right? Now remember, we said that was equal to a over x minus 3 plus b over x minus 3 squared, quantity squared. And what we have here, guys and girls, ladies and gentlemen, we have a is 1 and b is 5. And that's what I want to turn over and do this on the other side. I don't want like all this clutter up right here. By the way, incidentally, we could put this right here and put dx in here, and put this over here and put dx right here. Right? Let's turn it over where we have some room, okay? Alright, x plus 2 over x squared minus 6x plus 9. Okay, so we have, let's get a different color. We're integrating x plus 2 over x squared minus 6x plus 9. And let me show you the reason why we cannot do it any other way. If I were to let this denominator, let u be equal to, it would be nice if this were an ln problem right off the bat. If I let du is 2x minus 6. Even if I factor out the 2, I've got x of, well, dx. I don't have the exact same thing up here. I have an x plus 2 up here. Alright, so I cannot let that happen there. Okay, so I've got to use this partial fraction method. You remember what a was? A was 1, b was 5. We had x minus 3. And then we had x minus 3 squared, didn't we? Okay. This one, 1 times dx is just dx. Okay, we can, well, 1 dx. It doesn't matter. Let's leave it up there. You recognize what this one is? Yeah, it's ln, right? And again, you don't have to let u be x minus 3 because du is equal to dx. And if I did this, I would have du over u, which is equal to ln of u. But remember, u is simply x minus 3, so, well, plus c, okay. X minus 3 and absolute value bars plus c. And so if you see this exponent being a 1 down here like this, you don't have to do all that. Just get to the point where you just say, well, this, instead of doing all of this, just say, well, this is ln. Okay, so this is 1 times ln, or just ln, of x minus 3. Absolute value bars simply because ln cannot be negative here. Right. This argument, this is called an argument inside here, this cannot be negative. Okay, now plus 5, and I'm integrating. Oh, I need my dx here. Now this is not an ln here because this is squared, okay? So dx over x minus 3 squared, okay? It's different because, well, if this square was gone, then I'd have ln on this one as well. Well, I don't. So let's figure out what we can do here. Remember, if we have a power down here, we can bring it up here. Let's say like a over b squared is equal to a b to the negative 2, isn't it? Okay, like that. See what I mean? Okay. All right, I can bring that b up. I'm bringing this up and making it negative here. So this side here, we already know it's ln of x minus 3. Alright, now 5. And I'm going to bring this up right here. Alright, x minus 3 negative 2 to the negative 2 dx. If you hear a noise, that's people working on our attic. We're putting in new insulation on our attic and everything, so that's why the noise. Alright, I hope you can hear what's going on here. Alright, so we have this right here, and again, you don't have to let u be that, okay, but we do have this. This is u to the negative 2, okay, and then of course du, well, I'm sorry. If I integrate u to the negative 2 du, then this is, remember, you're adding 1 to that. So now it's equal to u to the negative 1 over negative 1, right? Okay. And then actually we can put the negative 1 here out in front. So negative 1 u to the negative 1 there. Okay. And so I can, okay, so this is what I have. So again, I'm going to add 1. So this is, well, ln x minus 3 plus 5. And of course this is going to be x minus 3 to the negative 1 over negative 1 plus c. Now 5 over negative 1 is actually negative 5, so I could make this negative 5 here. Okay, like that. Negative 5. Get that 5 looking better. And that would be okay, but I do like, if I got a to the negative 1, I like to have 1 over a to the positive 1. So that way I can keep my exponent positive. Alright, let's erase some of this here. I hope I don't run out of time on this video, I tell you. I would be crushed if that happened. Okay. Alright, I'm just going to put it up here now. Alright, so really this is equal to ln x minus 3. Now remember, this was plus 5, but I had a negative 1 down here, so that's minus 5 now. Minus 5 over, okay, minus 5 over, okay, 5 over, and then x minus 3 to the positive 1, but that's just x minus 3. Okay. Alright, I don't even need the parentheses around that. And then plus c. Alright, that's what I have there, and that's what you get. Now, again, if you take the derivative of all this, you should get that back. If you don't, then we made a mistake somewhere, but I'm not going to do that in case I run out of time like I did last time. But again, on the problem, when we had this over here, when we did integrate, just by way of review, I think I do have time for that. Okay, I don't have much time, but when you have this right here and you're integrating and you had the 1 over dx over x minus 3, this is ln automatically, okay? But it's different here when we had that plus 5 here and we had x, and let's see, yeah, okay, we had x minus 3, oh, I'm trying to think here, yeah, we had 5, yeah, dx over x minus 3, we had that squared. You can bring that up, make this a negative 2 here, okay? That's different. This is not an ln, and just be aware that just because it looks like this does not make this ln, because you don't have an exponent of 1, you have an exponent of 2. You have to bring that up, and then of course you add 1 to it. That's going to make that negative 1, and then the negative 1 would have come down here, making this negative 5 here, okay? And then I just like to bring this down right here like this in my final answer. This is the final answer here. And always don't forget the plus c on the end. Okay. And I appreciate your comments. I know it took a little bit. We've been doing greenhouses yesterday, my wife and I, and we got a few attic problems that we've having to contend with there, putting in some new insulation there. And so that's it's going to be a good thing. House is going to be a little warmer in the winter time and a little cooler in the summer, and that's what we want here. But anyway, this is KP the Math G. Please, I appreciate everyone, all your comments. If you want to make a comment, please do so about this video, or even about say, KP, I would like to see another one of those problems, you know, like the problems on the AP exam. I want to see more of those, and if you say that, I will put those on there. But I did want to cover this, and I said I would alternate back and forth from a textbook problem to back over here, because we need to know how to do this as well. So anyway, please comment, please hit the subscribe button, and I do appreciate it if you do subscribe. Again, I'm not going to twist your arm to say subscribe or not subscribe. I mean, if this helps you and you don't want to subscribe, that's okay, but it does help if you do subscribe. And if you like the video, I do appreciate that as well. Alright, anyway, this is KP the Math G signing off, and I hope and trust that you have a really, really great day. Have a nice day.